Hello everyone. Today our topic is inverse functions. Consider a one-to-one correspondence f from the set A to the set B. Because f is an into function, every element of B is the image of some element in A. Furthermore, because f is also a one-to-one function, every element of B is the image of a unique element of A. Consequently, we can define a new function from B to A that reverses the correspondence given by f. Definition of the inverse function. Let f be a one-to-one correspondence from the set A to the set B. The inverse function of f is the function that assigns to an element B belonging to the set B the unique element A in the set A such that f of A equals B. The inverse function of f is denoted by f to minus 1. Hence, f minus 1 of B equals A when f of A equals B. The inverse of a one-to-one corresponding function f from A to B is the function g B to A holding the following property. If f of x equals y, this implies that g of y equals x. If a function f is not a one-to-one correspondence, we cannot define an inverse function of f. This is because when f is not one-to-one correspondence, either it's not one-to-one or it's not onto. If it is not one-to-one, some element B in the codomain is the image of more than one element in the domain. Like in this case, this is not one-to-one function. If it's not onto, for some element B in the codomain, no element A in the domain exists for which f of A equals B, which means that some elements of the codomain are not used. This is not an onto function. This means that if it's not a one-to-one correspondence, we cannot assign to each element B in the codomain a unique element A in the domain such that f of A equals B. So a one-to-one correspondence is called invertible because we can define an inverse of this function. A function is not invertible if it is not a one-to-one correspondence because the inverse of such a function does not exist. In this figure, we have the graphical representation of the inverse of the function f. Here we have f of A and the inverse minus 1 of B. Example 1. Let f be the function from a, b, c, d to 1 to 3 such that f of A equals 2, f of B equals 3, and f of C equals 1. Is f invertible? And if it is, what is its inverse? The function f a, b, c in the domain 1, 2, 3 in the codomain. F of A equals 2, f of B equals 3, and f of C equals 1. So the function f is a one-to-one function and into function. We say that the function is one-to-one correspondence, which implies that the function f is invertible. The inverse function f minus 1 reverses the correspondence given by f. So f minus 1 of 1 equals C, f minus 1 of 2 equals A, of 3 equals B. Example 2. Let the function f z to z be such that f of x equals x plus 1. Is f invertible? And if it is, what is its inverse? The function f is invertible since it's one-to-one correspondence. To reverse the correspondence, suppose that y is the image of x so that y equals x plus 1. Then x equals y minus 1. This means that y minus 1 is the unique element of z that is sent to y by f. Consequently, the inverse function f minus 1 of y equals y minus 1. Next example, let f r to r be defined by f of x equals 3x plus 4. Find the inverse function f minus 1. We want to find the function f minus 1 that takes the value y as an input and spits out x as the output. y equals f of x gives y as a function of x. And we want to find x f minus 1 of y. That will give us x as a function of y. We just take the expression y equals 3x plus 4 for y as a function of x and solve for x. 3x equals y minus 4, x equals y minus 4 over 3, which is y over 3 minus 1.25. So the inverse of the function f minus 1 y equals y minus 4 over 3. Also, another example is the function f of x equals x squared. Invertible? The answer is no. If we apply to this function the horizontal axis, we have 2 points that intersects with the function. So this function is not one-to-one correspondence, and therefore it's not invertible. For today, that's all. Thank you.